In today's project, I will show you how to build a compact temperature and humidity monitor using the ATtiny85 microcontroller, a DHT sensor, and a 0.96 OLED display. Despite its teeny size, the ATtiny85 can easily read sensor data and display real-time temperature and humidity values on the OLED screen. So let's get started. For this project, you will need ATtiny85 microcontroller, DHT11 temperature and humidity sensor, SSD1306 OLED display, breadboard, and some jumper wires. The ATtiny85 is a small low-cost 8-bit AVR microcontroller from Microchip. It is commonly used in compact electronic projects because of its small size and low power requirements. The ATtiny85 provides 8 KB of flash memory, 512 bytes of SRAM, and 512 bytes of EEPROM, along with the digital I/O analog to digital conversion, PWM, timers, SPI, and I2C compatible communication. The commonly used DIP version has 8 physical pins, of which 6 can be used as a programmable input-output pins, while the other 2 are dedicated to power and ground. Starting from pin 1, it is PB5, which can function as a digital I/O pin or reset. Pin 2 is PB3, which can be used as a digital I/O pin, ADC3. Pin 3 is PB4, providing digital I/O, ADC2. Pin 4 is ground, which is connected to the ground of the power supply and circuit. Pin 5 is PB0, one of the most commonly used pin, and it can function as a digital I/O, MOSI for SPI, and SDA for two-wire communication, as well as supporting PWM and other alternative functions. Pin 6 is PB1, which provide a digital I/O, MISO for SPI and PWM functionality. Pin 7 is PB2, which can be used as digital I/O, ADC1, SCK for SPI, and SCL for two-wire communication, and an external interrupt. Finally, pin 8 is VCC, which is the positive power supply connection for the ATtiny85. First, connect pin 1 of the ATtiny85, which is the reset pin, to pin 10 of the Arduino Uno, which is used as a slave select pin. Next, connect pin 4 of the ATtiny85, which is ground, to the ground pin of the Arduino. Now connect pin 5 of the ATtiny85, which is MOSI, to pin 11 of the Arduino, which is the Arduino MOSI. Then connect pin 6 of the ATtiny85, which is MISO, to pin 12 of the Arduino. Next, connect pin 7 of the ATtiny85, which is SCK, to pin 13 of the Arduino. Finally, connect pin 8 of the ATtiny85, which is VCC, to the 5V pin of the Arduino Uno. There is one more important connection we need to make on the Arduino Uno. Connect a 10 microfarad electrolytic capacitor between the reset and ground pin of the Arduino. Make sure the positive leg of the capacitor is connected to reset and negative leg is connected to ground. This capacitor helps prevent the Arduino from automatically resetting while it is being used as an ISP programmer. So these are all connections we need between the Arduino Uno and the ATtiny85. Before moving to the next step, carefully check each connection to make sure everything is wired correctly. Next, upload the code to the ATtiny85 using the Arduino IDE. The program reads temperature and humidity values from the DHT sensor and continuously update the OLED display every few seconds. Make sure you have installed the required libraries for DHT sensor and the SSD1306 OLED display. Now we will connect the DHT sensor with ATtiny85. The wiring is very simple. Connect the DHT sensor VCC to 5V and ground to ground. Connect the DHT data pin to PB1 of the ATtiny85 GPIO pin. For the OLED display, connect VCC to 5V, ground to ground, SDA to the ATtiny85 SDA physical pin 5, which is PB0, SCL to the ATtiny85 SCL physical pin 7, which is PB2. Double check all the connection before powering the circuit. Now it's time to test the project. I have powered up the ATtiny85 circuit, and as you can see, the SSD1306 OLED display is showing the current temperature and humidity value received from the DHT sensor. To demonstrate that the sensor is working correctly, I will carefully bring a soldering iron close to the DHT sensor. I am not touching the sensor directly. I simply using the heat generated by the soldering iron. As the sensor detects the increase in temperature, you can see the temperature reading on the OLED display start rising in real time. This confirms that the ATtiny85 is successfully reading data from the DHT sensor and updating the OLED display continuously. This simple demonstration proves that the system is functioning correctly and can accurately monitor changes in environmental temperature and humidity. So that's it for today's project. If you enjoyed this video, don't forget to like, share and subscribe to the channel for more electronics and Arduino projects. The circuit diagram, source code and component list are available in the video description. Thanks for watching and I will see you in the next project.